Hello students, in this video we're going to be reviewing Interest Formula 1 and then seeing how that formula can be used to calculate loan payments. But first, let's do some practice questions with Interest Formula 1. Brenda invests $4,848 in a savings account with a fixed annual interest rate of 5% compounded quarterly. What will the account balance be after 6 years? Well, we're going to write out Interest Formula 1, A equals P parentheses 1 plus R over N, raised to the N times T power. The principal, the money invested, is $4,848. R, the interest rate, is 5%, and we're going to convert that into a decimal. So when you do that, you move the decimal point 2 places to the left. The time in years for this account is 6 years. And then the adverb in the problem. In this case, the interest is compounded quarterly. Quarterly means you get interest 4 times a year. So our N value is going to be 4. So we're going to plug back into that interest formula. And then we'll enter the expression into our calculator. So here we're going to have A, which stands for the balance. It's kind of weird that A stands for balance, but that's what it does. That equals the principal, $4,848, parentheses 1 plus R over N, 1 plus 0.05 over 4, raised to the N times T, 4 times 6 power. And I know that you know 4 times 6 is 24, but we're just going to enter the expression exactly this way right into our graphing calculator. So do that and put your photo in the box as we've always done. Make sure you enter the expression exactly as you see it. Also, make sure that you use your open and close parenthesis buttons, which are above the 8 and the 9. And make sure that 4 times 6, that's up in the exponent spot. And since we're dealing with money, we're going to round to 2 decimal places for dollars and cents. So here the balance is going to be $6,531. And this 7 rounds the 5 up to 6. So 96 cents. So that's how much is going to be in the savings account after the 6 years. Leah invests $8,333 in a savings account with an annual interest rate of 8% compounded semi-annually. What will the balance be after 12 years? So again, I'll write out my interest formula and I'll plug in my variables. So here we're going to have P, the principal. That's $8,333. The interest rate R is 8%. So let's convert that into a decimal. So that's going to be 0.08. T, the time in years, that's going to be 12 years. And N, how many times per year you get interest. Semi-annually, like a semicircle, there's 2 halves of a circle and a full circle. So 2, that's why semi-annually you get interest 2 times a year. So we're going to plug into our interest formula and then evaluate the expression right on our calculator. So here we're going to have the principal, $8,333, parentheses 1 plus R over N, 1 plus 0.08 over 2, raised to the N times T, 2 times 12 power. And we're going to enter this expression exactly as we see it right into our graphing calculator. Also, we're using the fraction template, the alpha y equals on our calculator, to enter in our 0.08 over 2. Enter that directly as you see it into your calculator. So the balance in the account is $21,360. And the 3 keeps the 1 as is, so 1 cent. So that's how much will be in the account after the 12 years. These next two ask you to calculate the account balance like we did in the first two, but we're also going to be calculating how much in interest the account earns. So Jasmine invests $2,658 in a retirement account with a fixed annual interest rate of 9% compounded monthly. What will the account balance be, and find the amount of interest earned? Well, the principal, $2,658. Our interest rate are 9%. So that's going to be, when we convert that into a decimal, 0.09. The time in years is going to be 15 years. And N, how many times per year you get interest? The problem says monthly. So that means you get interest 12 times a year. So we're going to do on our calculator, the principal, $2,658, parentheses 1 plus R over N, 1 plus 0.09 over 12, raised to the N times T, 12 times 15 power. Now this is going to give us what A is, and remember A represents the balance, how much money is in the account after the time, after the 15 years has gone by. So carefully enter this expression into your calculator and put the photo in that box there. So the balance in the account is going to be $10,201, and the 9 makes that 52 cents. So that's the answer to the first part. That's what the balance is going to be. That's how much money you have in the account after the time, after the 15 years has gone by. Now, the way we calculate the interest is basically the extra money that you make. So for example, you put $2,658 in the bank. You now have over $10,000 in the bank. So what we're going to do is we're going to take the $10,201.52 and we're going to subtract the $2,658. That's how much extra, that's how much interest you make. So the way you calculate the interest is you take the balance that you found in the first part and you subtract the principal, how much money was put into the account at the beginning when you took out the account. So we're going to subtract these two values. So here the interest that you make, and make sure you add this photo into the box, $7,543.52. So the interest is basically why you open up the bank account. You basically want to keep your money safe, and then you earn interest while putting the money safely in the bank. So you earned an extra $7,543.52. So the interest is how much extra money you make by keeping the money in the account. Let's try one more of those interest problems. Maria invests $6,154 in a savings account with a fixed annual interest rate of 8% compounded weekly. What will the balance of the account be after 10 years, and find the amount of the interest earned in the account? So A equals P parentheses 1 plus R over N raised to the N times T power. Our principal is $6,154. Interest rate R is 8%. So when we convert that to a decimal, that's going to be 0.08. T, the time in years, says it's going to be 10 years. And the interest is compounded weekly. And since there are 52 weeks in a year, that means if you get interest once a week, you get interest 52 times a year. So N is going to be 52. So I'm going to have the principal, 6,154, times 1 plus R over N, 1 plus 0.08 over 52, raised to the N times T, so that's going to be 52 times 10 power. And this is going to give you A, which represents the balance, how much money is in the account. So take a minute, enter this expression into your calculator to figure out what the balance is going to be after the 10 years the money has been in the bank. Take your calculator photo and put that in the box for this first part. So here our balance is going to be $13,687, and the 1 keeps the 6 as 56 cents. So that's what the balance is going to be. And then the way we calculate the interest, how much extra money we make, we're going to take the balance and then subtract the principal, how much money was put in the account. So we're going to take the $13,687.56 and subtract the $6,154, and that's going to be what the interest is. So the interest earned in this account, $7,533.56. So that's how much extra money you made by keeping the account in the bank for these 10 years. Now let's look at how we can use this interest formula to figure out when you take out a loan, how much it's actually going to cost you. Your 8-year loan of $12,200 is at 5.3% compounded annually. How much will you have paid in total for your loan? So you're borrowing $12,200. How much you're borrowing is going to be the principal in our interest formula. A equals P parentheses 1 plus R over N raised to the N times T power. So our principal is going to be $12,200. Here the interest rate is 5.3%. So since R is 5.3, we're going to move the decimal point 2 places to the left. So it's going to be 0.053. So our R is 0.053. Now, here it says it's compounded annually. Annually means that it happens once a year. So even though you're going to be paying your interest and paying your loan every month, we're going to use N as 1 for annually. Raised to the N times T. Well, N is 1. Here it says you're taking out an 8-year loan, so T is going to be 8. So you basically plug in the values just like we did for the previous problems. Our principal is how much you're borrowing. Our interest rate, 5.3%, so 0.053. N compounded annually, so N is 1. And T, the time in years, it said it was 8 years. So we're going to carefully now enter this expression into our calculator to figure out how much this loan is really going to be costing us. So it works essentially the same way as the previous problems did. So here it looks like the balance is going to be $18,441, and this 9 makes the 9 cents turn into 10 cents. So this is how much it cost you for your loan. And if you think about how this works, you're borrowing $12,200. You need that to buy a car, to fix your house. So you need a little over $12,000. So the bank gives you the loan. The bank gives you a check for $12,200, but you end up paying the bank back for that $12,200. You end up paying the bank back $18,441.10. So even though you're only borrowing $12,000, you're paying back over $18,000. So that's how much you pay for that $12,200 loan. Now, in this last problem, here we're going to be purchasing a beautiful car, a 2020 BMW 13. And here the price of the car is $45,445. So that's going to be the principal. That's how much money you're borrowing. You wish to purchase this car. You take out a loan for 6 years. So here our time is going to be 6 at 7.75% interest. So our R is 7.75%. So we're going to take the decimal point and go 2 places to the left. So here our R is 0.0775. The loan is for 6 years. So our interest rate R is 0.0775. And for these loans, what you do is you always calculate your payments annually. So our N is going to be 1. Just like in the last problem, our N is going to be 1. So we're going to buy this BMW, which is costing a little over $45,000. Let's see how much it really ends up costing us. So I'm going to plug back into the interest formula. So I'm going to have the principal, $45,445. That's the price of the car. That's how much your loan is. So that's the loan amount. That turns into the principal. That equals, let's see, $45,445, parentheses, 1 plus R over N. 1 plus 0.0775 over 1, raised to the N times T, 1 times 6 power. Now this one here is asking you, how much in interest will you pay? Well, the first thing we did when we calculated interest in those bank account problems is we found out what our principal is. Now, our principal is going to be how much the loan is actually costing us. So we're going to carefully enter this expression into our calculator. We're borrowing a little over $45,000. Let's see how much, though, we end up paying back. So it looks like the balance, how much we end up paying the bank back, $71,119.68, because the 7 kicks the first 7 up to 8. So that's how much you end up paying back. So $71,119.68. But that's not how much you borrowed. See, this is how loans work. You need to borrow money. So the bank says, oh, here you go. Here's a check for $45,445. You hand that over to the BMW dealership, and you're happy because now you're driving a BMW. And you're paying this back over 6 years. So every month for 6 years, you're going to be paying the bank back for this car. Well, after the 6 years, you paid back over $71,000. See, the bank gave you $45,445, but you paid the bank back over $71,000 for this car. So the way we're going to calculate the interest is basically what we did for the bank account problems. We're going to take the balance, which is this $71,119.68, and we're going to subtract the principal, which was the loan amount. So we're going to do $71,119.68 minus the $45,445 that we actually borrowed for the price of the car. So we're going to do this subtraction, and that's going to tell us how much extra money we paid the bank back. So here in interest, we're paying $25,674.68. That's how much in interest this loan is costing us. See, and it's kind of shocking when you first do the math for this. You want to buy a $45,445 car. So the best thing to do is save up this much money, and then you're done. You pay that to the BMW dealership, and then the transaction is done. But most people don't have $45,445 in the bank. So they take out a loan. They, of course, pay back the money they borrowed, but they pay back a lot more. They pay back over $25,000 extra, and that's what's called the interest. So we're going to be practicing these business type of questions over the next several weeks of our semester.